All right, so in this video, we're going to go through sample question 99 from the Society of Actuaries ExamP list of sample questions. The question reads, an insurance policy pays a total of, pays a total medical benefit consisting of two parts for each claim. Let X represent the part of the benefit that is paid to the surgeon. Let Y represent the part that is paid to the hospital. The variance X is 5,000. The variance Y is 10,000. And the variance of the total benefit is 17,000. Due to increasing medical costs, the company that issues the policy decides to increase X by a flat amount of 100 per claim and increase Y by 10% per claim. Calculate the total variance. Calculate the variance of the total benefit after these revisions have been made. Okay, so what I'll first say is super wordy, right? There's a lot here, and sometimes it's hard to kind of decipher what they want. However, all in all, this is not a difficult problem. It seems like you just need to know some facts about calculating variance and covariance. All right, so first let's figure out the total, like what are these values after the revisions, after the increase in price, right? X is going to go from just being X to being X plus 100. And Y increases by 10%, so Y is going to go to 1.1 Y. And I need to calculate the variance of the new total benefit, right? X plus 100 plus 1.1 Y. So it seems like we're going to need a couple of facts going into this. The first one being the variance of X plus Y is equal to the variance of X plus the variance of Y plus the covariance, plus 2 times the covariance of XY. Right? That'll be important in a second. We're going to use it in conjunction with this piece of information. So, calculating the variance here of X plus 100 plus 1.1 Y. Now, you should know that when you are calculating a variance and you're adding a constant inside that variance, it's equal to the original thing. So, for example, the variance of X plus 100 should just be equal to the variance of X. So therefore, the variance of X plus 100 plus 1.1 Y should be equal to the variance of X plus 1.1 Y. Right? Simple as that. Now I'm going to use this formula to expand this. So the variance of X plus 1.1 Y is equal to variance of X. Lucky for us, the question actually gives it to us, plus the variance of 1.1 Y plus 2 times the covariance of X 1.1 Y. Right? Almost ran out of room there. All right. Another rule we need to know. When we have a constant being multiplied to our random variable inside of variance, we can do the following. So this obviously stays as the variance of X plus 1.1 squared times the variance of Y plus 2 times the covariance of X 1.1 Y. Okay, now another rule you should be familiar with. And I'm going to grab a separate sheet of paper because there's actually quite a lot of like formulas that you kind of memorized for this question, it seems. The covariance of, let's say, A times X, comma, bx by, sorry, where a and b are constants is equal to the following: ab times the covariance of x comma y. So I can rewrite the following. I'm going to kind of move it over to the side here just so I have more room. Variance of x has stayed variance of x this whole time. I'm going to square this 1.1, should be 1.21 times the variance of y. And then 2 multiplied by 1.1, which is 2.2, covariance of x comma y. And we're pretty much almost done. I'm going to start filling in these numbers. We know the variance of x is 5,000 plus 1.21 times the variance of y, which is 10,000. Plus 2.2 times the covariance of x and y. Now, that is not given to me directly. What we're given is the variance of x plus y, and I'll use this formula to actually find the covariance of x plus y. So let's do that right here. Variance of x plus y is equal to the variance of x plus variance of y plus 2 covariance x comma y. And this is going to be equal to 17,000, which is equal to 5,000 plus 10,000 plus 2 covariance x comma y. And solving for this, this will be 15, so this will be, making sure I'm doing this correctly, right, 15,000, 17,000 minus 15,000 is 2,000, which is equal to 2 times the covariance of x comma y. So 1,000 is equal to the covariance of x comma y. Now that we found that out, little substitution here. And this is just a string of things I can put into my calculator, right? TI-30X, the recommended calculator for ExamP, and also bring it to FM. So 5,000 plus 1.21 times 10,000 plus 2.2 times 1,000. And that's equal to 19,300. And that lines up with answer choice C. Okay, so let's go over what we just did here. We're given a load of information, right? But all in all, it can be condensed to this. We have a random variable x with a variance, a random variable y with a variance, and the sum of x and y have a variance of 17,000, right? So we're given 3 variances. Then we're told x and y increase by some amount, one by a flat rate, one by a percentage. And we're asked to find the variance of this new total, right? So we figured out, okay, what are they asking us? They're really asking us for the variance of x plus 100 plus 1.1y. And then we need a few rules and formulas to do with variance. First being the fact that the variance, the sum of the variance of the sum of 2 random variables is equal to the variance of the first random variable plus the variance of the second random variable plus 2 times the covariance of both random variables. Another thing we need is that, the following. I'll write it here. And this should be on whatever formula sheet you're using. The variance of ax plus b, where a and b are constants, should simply go to a squared variance x. And the third thing you're going to need to know is that the covariance of ax comma by, where x and y are random variables, a, b are constants, is equal to ab covariance x comma y. After that, it's just kind of like a little algebra puzzle for you to solve. That should cover it. If there are any questions, anything else you want me to go over, throw it down in the comments. I'll answer to the best of my abilities. And if this video helped you out, hit the like button and subscribe, because that totally helps me out. If you want to see more videos like this, I got a playlist. I'm growing every day. Check it out. Linked in the description and the end of the video. But other than that, thanks for watching, and I hope this helped.